Hello everyone, this is chapter 2, part 19, labor economics. In this part, we will learn about quasi-experiments or natural experiments, and we will learn about difference and differences estimator. We're going to learn this in the context of the impact of earned income tax credit and mother's labor force participation rate. So if we go to the previous part, we found that earned income tax credit can create two distinct effects on labor supply. Number one is it's expected to increase the number of participants to enter the labor force. Okay, so let's see if this actually works. And we use something called natural experiment, quasi-experiment. Why? Because we sometimes cannot run real experiments. For instance, you have two groups of mothers, A and B, right? You randomly choose two groups of mothers single mothers in a city. Group A gets their earned income tax credit benefit cut. Group B keeps this benefit, right? And then you look at their labor force participation rate. What's wrong with this kind of experiment? Let me tell you what's wrong. It can be unethical and immoral, actually, because you're playing with people's livelihood. You're randomly assigning this. This could be done in a different way. And we'll talk about natural or quasi-experiments. Quasi-natural experiments are being used in economics when we cannot set up randomized trials. It happens for many public policy situations, okay? So time series and cross-sectional approaches, often they are unsatisfactory. What does it mean? So if you look, for instance, a policy change, let's say 2022, there was a policy change, and you look at before and after. You look at before and after. I apologize with all this craziness. 2020, you look at before and after. Okay, so my mouse is still acting up. It's not gonna give you the full picture because before and after, some other things have changed as well in this time period. When we look at cross-sectional approaches, so you're looking at different groups of mothers, right? That is going to yield unsatisfactory results because, for instance, single mothers from different backgrounds are going to have different behaviors, okay? So we use what we call quasi or natural experiments. So this is basically changes in the economic environment. This is policy change, okay? That creates a roughly identical treatment, T4 treatment, and control groups to study the effect of a policy change, okay? So what we do is, we let outside forces to do the randomization for us. How does it work? For instance, two states, state A and state B, so Texas and Oklahoma, right? These are neighboring states in United States of America. So if two states have similar policies, Texas randomly changes, okay? So then you have treatment group, Texas, the policy change happening state, versus control group, the state that didn't have policy change. So outside factors are doing the randomization for us. In some cases, it happens naturally. That's why we call natural experiment. So let's take a look at this example. Suppose that Arkansas cut the temporary assistance to needy families benefit. Okay, this is a cash benefit by 20% in 1997. Okay, so Arkansas is doing this random cut by 20%. So we had a large sample of single mothers in Arkansas observed 1996 and 1998. So 1996 is before this policy change. 1998 is after the policy change. And Arkansas is a treatment group. Let's continue. You also need a control group, okay? At the same time, imagine that Louisiana's benefits remained unchanged. So you can also look at Louisiana before and after, but the benefits didn't change, all right? So alteration in the state's policies yield natural experiment or randomization. So women in Arkansas, where the benefits were cut, experienced a decrease in benefits, are what we call the treatment group. Women in Louisiana whose benefits were unchanged are the control group. Okay, so remember, in lab experiments, they test the drug on two groups, right? They give the real medicine in one group, they give placebo in the other group, right? To the other group. So medicine given group is the treatment, placebo given group is the control. So same thing. So what we do is we compute the change in labor supply across these groups, examine the difference between treatment, Arkansas, and control, and obtain an estimate of the impact of benefits on labor supply free from bias. Okay? Why not to study single mothers in Arkansas only, right? Why don't we just focus on Arkansas? Because Arkansas performed an experiment, okay? So, you can say like, well, Arkansas performed the experiment. Single mothers in 96 are the control and 98 are treatment group. Why can't we do this? This is a really bad idea. Why? Because even between those two year groups, before, after, there has been some changes. What if the national economy was growing fast during this period? So you're going to see labor force participation is growing from 96 to 98, and you can attribute that to the cut in benefits and mistakenly conclude, oh, benefits were cut, everybody started working, so we should cut all benefits. So that would give us biased results. So quasi-experiment approach is an extra step of comparing the treatment group from the policy change to a control group for whom the policy did not change. Single mothers in Louisiana didn't experience this benefit cut, yet benefit from the growth of economy is experienced by single mothers in Louisiana. Okay? So what we do is we examine hours of work in Arkansas. So you look at hours of work in Arkansas, okay, control group, after. So what we do is usually, so you look at Y treatment, okay, Y is the outcome we're looking at. Here it's hours, right? So you look at hours. Oh my gosh. This program will not let me. Y treatment, outcomes of treatment. You have outcome in the treatment group. You have to put after, okay, minus outcome, treatment before. So this is the first part of the treatment outcome changes. Okay, first part of the estimator. So examine hours. So hours, treatment group, Arkansas, after, minus treatment group, Arkansas, outcome hours, before. Contains both the treatment effect and the bias from the economic boom. So after, before, you can, put different time periods. So we have treatment effect of benefit cut and bias from any economic boom or bust that is happening potentially in that period. We then examine hours of work in Louisiana. Okay, so outcome again. We're looking at outcome hours of work. This is your control group results. So what we do, outcome hours. You look at control group after minus outcome hours, control group before. Okay, so hours of work in Louisiana, control group after, hours of work Louisiana before. So this contains only the effect of economic boom, and there was no policy change in the state group. Subtracting the change in hours of work in Louisiana treatment group minus the control group from that in Arkansas, we control for the bias caused by economic boom or anything that happens in that period. So we can obtain a causal estimate of the effect of benefit cut, temporary assistance to needy families benefit cut on hours of work. So here is actually numbers, okay? So benefit guarantee was $5,000 in 1996. And this is hours of work per year, 1,000 hours, before, after. So Arkansas is your treatment group, okay? So benefit cut from $5,000 to $4,000, benefit cut by $1,000, negative 1,000. Hours of work has gone up by 200 hours, okay? So difference is plus 200. Benefits fell by $1,000 in Arkansas during 1997. CPS data shows actual hours of work of single mothers in Arkansas. At the same time, benefits were being cut. Hours of work increased for single mothers in Arkansas. Okay? Benefits fell by 20%. Hours increased by 20%. Elasticity of labor supply with respect to benefits is -1, right? You do 20% increase in hours minus cut in benefits. Okay. However, there's bias in this first difference. So this is called the first difference because a major economic growth during this period. Okay. So single mothers in Arkansas may have increased their work effort even if benefits had not fallen. Okay. So to account for this, you need to look at single mothers in the neighboring state of Louisiana. Okay. So now you have before, after, right? Difference, after minus before, after minus before, after minus before, after minus before. This is the treatment group. This is the control group. Benefits guarantee didn't change in Louisiana, $0 difference. Hours of work per year has gone up here too by only 50. So we can gather the same kind of data on Louisiana. And labor supply still increased, maybe due to growing economy. Okay. So it appears that 50 hours of the 200-hour increase was due to, so it looks like 200-hour increase happened here. Guess what? 50 of it it is due to economic growth, some other trends. Okay. So what do? We use difference and differences estimator or double differences estimator. This is the difference between changes in outcomes for the treatment group that experiences intervention and a group that does not. So after, before, for Arkansas treatment group, after, before, minus before 200, and do treatment group after 1100 minus 1050, 50. So then treatment group difference 200 minus control group difference. It's called double differencing. So cross-sectional analysis would be reduction in welfare benefits leads to 100-hour increase in work. How did you do cross-sectional analysis? If you looked at this whole sample, okay, 100 hours of work increase. Difference and difference says 150-hour increase. Okay, how did we do it? This is your treatment group, hours, treatment group change minus hours, control group change. So treatment group hours after, before, calculate this. This was 200 hours, right? Minus, so I'm going to write down numbers. After it was 1200 hours minus 1000 before, 200-hour change, minus, keep everything in parentheses. What was the Louisiana after hours? It was 1100, okay, 1050. So we're looking at Louisiana after 1100 hours before 1050. Okay, so here you have 50 units, change in the control group, 50 units. So 200 minus 50, 150 hour increase is attributable to the benefit cut. So the second term for Louisiana nets out the bias from the growing economy. The causal effect of temporary assistance to needy family benefit cut would be 150-hour increase in labor supply. So what's the elasticity? You have not 20% increase in labor supply. So you cut benefits by 20%. Your labor supply increased by 15%, right? 150 over 1,000. So this is going to be 0.75, okay? So let's talk about potential problems with quasi-experiment analysis. It's possible that the economic boom affected Arkansas and Louisiana differently. Single mothers may be different across states. We can never be completely certain that we got rid of all the bias, treatment control comparison of bias. However, this is a great tool. So two drawbacks: only provide an estimate of the causal impact of treatment. It's difficult to extrapolate beyond the changes in policy. So it's hard to say what will happen if we cut benefits by 43% in the future, because it's really going to be different economic times. Often it does not tell us why the outcome changed, so we cannot separate income and substitution effects. However, randomized trials and quasi-experiments are very useful. So what I did in this slide, I'm doing on one hand, on the other hand, stuff we do as economists. So we also have reduced form estimates. Right, these are the reduced form estimates. I misspoke. These are reduced form estimates. It leaves much of the economic theory in a black box, which means we can't really differentiate between income and substitution effects, but still we are measuring the impact of this policy change. So empirical evidence, earned income tax credit draw more people to the labor force. So this is how we started our PowerPoint slide. So this is a study by Issa and Liebman, 96 study, used difference in different estimators on the 1996 Tax Reform Act, okay? So labor force participation rate before legislation, after legislation. So remember, earned income tax credit was changed, okay? So it became, right, effective. All right, so earned income tax credit is here becoming legislation in this period, right? So we have treatment group. These are the eligible mothers, single mothers eligible for earned income tax credit. This is their labor force participation rate. 72.9% of mothers participated in the market before. After, 75.03% of single mothers participated after the legislation, after this earned income tax credit. So difference is after, before, labor force participation rate, 75.3 minus 72.9, 2.4%. So please do after, before. What's the control group change? These are also single women. However, they have no children, okay? So they're not eligible for earned income tax credit. Look at this. When you don't have children, single women, in this time period, 95.2% actually were before legislation. These groups were not affected. And actually, their labor force participation rate stayed the same. That means there has been no major economic changes affecting these groups, potentially. So after minus before, 0%. So difference treatment minus control, 2.4%. So how can we say it in English? We can say difference and difference estimator says that 2.4% increase in the labor force participation rate for single mothers is attributable to earned income tax credit. So 2.4% more women are participating in the market. So as you can see, we just show the impact of that budget line shift becoming that kink budget line. Moral of the story, cash grants drop the labor force participation rate. This is temporary assistance to needy families. Earned income tax credit increases labor force participation rate. And I just want to give you general difference and difference estimator. Difference and difference estimator. This Y is any outcome we are looking at. It could be labor force participation rate. It could be unemployment rate. Anything. Okay. So you need to do change in treatment group, delta for change, minus change in control group, where the policy change didn't happen. So change in treatment group, Y. Oops. This happens, unfortunately. So Y, treatment, you put after, I don't know what year it is, I don't care. It could be years, months, minus outcome, treatment again, before number. Okay, minus outcome, control, after, minus outcome, control, before. Okay, so if we are looking at the labor force participation rate, difference and difference, you're going to do change in labor force participation rate for treatment group. These are with children. So labor force participation rate, PR, with children, after, minus labor force participation rate with children, before, minus labor force participation rate no kids, after, labor force participation, minus no kids, no children, before. Okay, so plug in these numbers, right? 75.3, 72.9. 75.3, 72.9. That's what we did. Okay. And 2.4, 95.2 before and after. So these are all 95.2. 95.2 minus 95.2. This is 0. This is 2.4 minus 0. So 2.4% increase in labor force participation rate of single women is attributable to this policy change. Please always write this down if you don't want to make mistakes. Because usually students, this is what students make mistake. So instead of doing after, before legislation change, they do before, after. So if you write down the formula, you will never make a mistake. I'll see you in the next part where we'll discuss labor supply over the life cycle.